Section 3, doing questions 28 to 32 on the math calculator section. Alright, question number 1. In planning maintenance for a city's infrastructure, a civil engineer estimates that, starting from the present, the population of the city will decrease by 10% every 20 years. If the present population of the city is 50,000, which of the following expressions represents the engineer's estimate of the population of the city T years from now? Okay, I would say a good way to do this would be to just plug in 1 for the number of years. So instead of t, just replace 1, and then work through the options to see which one fits. But we can cross out A and B because this is saying that you start off at 50,000 and then you would lose 90% every 20 years. But that's not what's happening. If I show you here why that's the case, let's say you did have, let's say 20 years did pass, right? So t would become 20. So you would have 50,000 times 0.1 to the power of 1 because it's 20 over 20. You see how after 20 years, you'd be left with 0.1 of 50,000, which is 90% loss? That's not right. So we want to, what happened? Okay, so it's not A and B. Let's plug in 20 years for C and D. So 50,000 times 0.9 to the power of 20 times 20. So to the power of 400. So does that make sense? No, that would be like in the that would be in the billions. Like that'd be a number way too big. This doesn't make sense. Here though, if you plug in 20, 50,000 to the times 0.9 to the power of 20 over 20, 0.9 to the power of 1, you'd be left with 50,000 times 0.9, which is you're left with 90% of your initial investment, which corresponds with what the question said. So it's D. Okay. The incomplete table above summarizes the number of left-handed students and right-handed students by gender for the 8th grade students at Keisel Middle School. There are 5 times as many right-handed female students as there are left-handed female students, and there are 9 times as many right-handed male students as there are left-handed male students. If there is a total of 18 left-handed students and 122 right-handed students in the school, which of the following is closest to the probability that a right-handed student selected at random is female? Note, assume that none of the 8th grade students are both right-handed and left-handed, so no ambidextrous students. Okay, so we have to fill in the table here. First, we have to initialize some variables. Let's say the variable for males, or let's say let females equal F, and let males equal N. Because we don't know the explicit number of males and we don't know the explicit number of females. But we do know the ratio between the left and right-handed people within that gender. So it says here there are 5 times as many right-handed students as there are left-handed female students. So there'd be 5 of F compared to 1 of F on the left. And there are 9 times as many right-handed male students as there are left-handed male students. So it'll be 9 of M for every M. Okay. If there's a total of 18 left-handed students and 122 right-handed students in the school, which of the following is closest to the probability that a right-handed student selected random is female? Okay, so we can make 2 equations. We can make this an equation and we can make this an equation. Let's write it down. So 9M plus 5F is equal to 122, and M plus F is equal to 18. From this table, we're able to say that there's a total, this is the total left-handed students, and this is the total right-handed students, and we got an equation for each. So now we just have to solve for one and then solve for the other, and then we can figure out the probability. Okay, so let's solve for male first. So actually no, let's solve for female first because using combination. So we want to subtract these equations and cancel one of the variables out. So we have to multiply this equation by 5, so 5f can cancel out. So 9m plus 5f equals to 122. And then multiply this one by 5, so you'd have minus, and then, because we're going to subtract, 5m plus f times 5 is 5f equals 18 times 5 is 90, I think. Let me just double check. 90. So let's subtract. 9m minus 5m is equal to 4m. 5f minus 5f is equal to 0. So 122 minus 90 is equal to 32. So that means we're just left with 4m is equal to 32. So m is equal to 32 divided by 4, which is 8. So if m is 8, plug it into this equation, that means f is 10. Now we know how many, the value of m and f. So let's just plug this into the table just to make it easier for us. So we know that there are 10 females, so that means that there's 10 left-handed females and 50 right-handed females. And there's 8 left-handed males and 9 times 8, 72 right-handed males. And this makes sense, you can double check. 10 plus 8 is equal to 18, and 50 plus 72 is equal to 122. So it all works. So now we just have to figure out the probability. Which of the following is closer to the probability that a right-handed student, so we're just looking at the table, the column with the right-handed people, student selected at random is female. So we know there's 50 female students who are right-handed, and there's 122 total right-handed students. So it would be 50 over 122, which is equal to 0.409, which is closest to A. All right, 30. And the equations above, B and C are constants. If B is C and minus 1/2, which of the following is true? All right, so we have 4 variables in this equation, and we have 4 variables and 2 equations. We should be able to, just given the nature of this problem, we should be able to simplify these 2 equations so there's only 2 variables and 2 equations. And they guide us with this first step, which is B is C minus 1/2. So we can just get rid of B. So we're only left with 3 variables, C, X, and Y. So if B is equal to C minus 1/2, we can plug that into the top equation. So 3x plus, and B is C minus 1/2, so C minus 1/2 is equal to 5x minus 7. And 3y plus C is equal to 5y minus 7. You see how we only have 3 variables now and 2 equations, but we're still not done yet. We still want to cut it down to 2 variables and 2 equations. And we can't change the number of equations, but we can change the number of variables. So since we have C in both of them, why don't we solve for C in one of the equations and then plug that value of C in terms of X and Y into the other one. So let's do that. So since C is already a whole number here, all we have to do is subtract 3y from the left equation, the left side of the equation, and find a value for C in terms of X and Y, or just Y. So C is equal to 5y minus 3y, 2y minus 7. Now we can plug this into this equation over here. So 3x plus C minus 1/2, so it'll be 3x plus 2y minus 7 minus 1/2 is equal to 5x minus 7. So great. Now we just have 2 variables and 2 equations, but we don't need the other one anymore because our answer has 2 variables in it, so we don't have to solve for one. Now we just have to solve for x, because that's what the answer choices are. They all want us to solve for x in terms of y. So, and we only have x and y here. Perfect. So let's just get rid of the bracket circuit. We don't need that. Let's brackets just make unnecessarily crowded. Okay. Now let's just solve for x. So 2y's here. Okay, so let's move the 3x to this side and the 7 to this side. So 5x minus 3x equals to 2x. So 2x is equal to 2y minus 7 plus 7 from the other side minus a half. So 2x is equal to 2y minus 7 plus 7 cancels out, and then we'd have negative 1/2 remaining. And we're not done, you're almost done. You just have to divide everything by 2 just to make x by itself. So x is equal to y divided by 2 is just y. 2y divided by 2 is just y. And then negative 1/2 divided by 2 is negative 1/4. So x is equal to y minus 1/4, which is a. X is y minus 1/4. Alright. Tickets for a school talent show cost $2 for students and $3 for adults. If Chris spends at least $11 but no more than $14 on X students and one adult ticket, what is one possible value of X? Alright, so let's say he spends $11, right? And he spent one adult ticket, so we subtract $3. So the remaining amount of money we have left is $8. So we know that he can buy four more tickets for students because they're only $2 each. So the answer is 4. Or there's also another answer, but that one should be fine. Alright, ages of the first 12 United States presidents at the beginning of their terms in office. The table above lists the ages of the first 12 United States presidents when they began their terms in office. According to the table, what was the mean age in years of these presidents at the beginning of their terms? Alright, now this is just annoying because we just have to add up these numbers and then divide it by 12. So just add up the numbers and divide it by 12 and you should get the answer. Let me just do that real quick. 57 plus 62 plus 58 plus 58 plus 59 plus 58 plus 62 plus 55 plus 68 plus 51 plus 50 plus 65. 703, that's the sum of all the ages divided by 12, because there's only 12 presidents, is 58.58. Well, the answer to the nearest tenth, so 58.6.